So welcome everyone to the Heat Pumps for Your Home webinar. Thank you very much for joining us. This webinar is essentially covering everything you need to know about getting a heat pump in your own home. And we've got some wonderful guest speakers joining us. So just to run through some housekeeping, the webinar is being recorded and we may turn on the live stream if we manage to figure out how to do it. So if you could please keep your microphone and also your camera off would really help the bandwidth. You can get all of your questions answered directly in the chat bar. So just pop them in the chat area. And you might be able to answer each other's questions, but do leave a few of them for our speakers as well. So thank you very much for joining us this Wednesday evening. I know many of you have donated towards this webinar and it is really, really appreciated because those donations all go towards helping us tackle fuel poverty and carbon emissions in South East London. The recordings are going to be available on the website afterwards, so just go ahead and visit www.futurefithomes.org/blog and you can find all the webinar recordings there. We've also got some previous events up on our website, so if you're interested in finding out about retrofitting your home for energy efficiency, so that's all about insulation and the best ways to stop your home from leaking heat and using too much energy, you can go and check those out on futurefithomes.org/blog. So just to briefly run through today's agenda, you'll be with me, Nadia, project manager and director at Celsie for the first 10 minutes. And I'm just going to talk a little bit about Futurefit Homes and what Celsie does. Then we're going to have an introduction to heat pumps from Jason Blanchard, who is also one of our directors at Celsie and works on installing heat pumps at ISO Energy. We'll then get into a presentation on upgrading your fuse and making sure that your heat pump really fits in well and supports the electricity system. And that is going to be presented by Rona from UK Power Networks. We'll have a quick question and answer after that, so you can get all your questions in and ready for that. And those questions will be on both Jason and Rona's presentations. And then we've got two wonderful guest speakers joining us for a panel discussion. And those speakers are Shivali, who works at the Department for Business, Energy and Industrial Strategy, and Dr. Richard, who is at the University of Exeter, both working on decarbonising heat and policy around that. And then back to me for a quick roundup of what you can get done today and finish off. So I just wanted to highlight why we're actually talking about using heat pumps and what it means for the UK carbon emissions. You might know that 22% of the UK's emissions do actually come from homes. So you can imagine that is a huge amount. And there's four main ways that we can help homes reduce their carbon emissions. The first is through using heating that is efficient and low carbon. And that's what this webinar is about today. The second is to reduce the amount of heat that you're losing from your home and reduce the energy that's lost. The third is to generate renewable energy. And a lot of you will already be doing that because I know that a lot of you have other bits of tech like solar panels or solar thermal as well. And the last one is buying energy efficient products. So making sure that your fridge, your cookers, your washing machines are at least A rated and maybe A++ rated as well. But I just wanted to touch on the second point here before we jump into our presentation about heat pumps. And that is about reducing the amount of energy that you use. We always say that the best carbon saved is the amount of carbon that's not used in the first place. So trying to reduce your emissions by reducing the amount of energy that you use is always the best solution to start off with. At Celsie, we can help you understand roof and loft insulation, cavity and solid wall insulation, floor insulation or underfloor insulation, and making sure that your windows are efficient and draft proofing any gaps around windows and doors as well. So a little bit about the Futurefit Homes programme. What we're aiming to do is offer a service that is tailored to your own needs, trustworthy and independent of installers, independent of people that are making money out of this, and impartial. We work with fully trained advisors, and you'll probably speak to David or Tristan if you do decide to come to us for some service, who are qualified retrofit coordinators and retrofit assessors. So they've got a huge amount of knowledge about energy efficiency and about decarbonising your home. We're also members of the Retrofit Works Co-op, and this is a cooperative of businesses and different kinds of organisations that are involved in making sure that homes are fit for the future, because really saving carbon emissions does start at home. All of the surpluses that we make through the Futurefit Homes programme go back into our fuel poverty and carbon emissions alleviation work. So supporting people that are really having to choose between heating and eating, because it is a really high number in South East London, and also making sure that people reduce their carbon emissions as much as possible. There are a number of services that you can access through the Futurefit Homes programme, and those include our free half-hour phone call with either myself, David or Tristan. So drop me an email if you're interested in getting that set up. We also offer one-to-one advice, so we can help you go through a number of things, whether it's quotes from installers or it's just finding out what the best solution might be for you. And that's at £59 per hour. Thermal imaging surveys are a really exciting a service that we offer, because you'll be able to see exactly where your home is leaking heat from. So it's really interactive and it's really good to see. And those start off at £299 for a 3-bedroom house. We also offer energy performance certificates. So you might know about these if you've recently sold your home, or if you rent out the property that you're interested in looking at. And these essentially grade your home on A to G rating of how efficient it is. We can't currently offer the thermal imaging and the energy performance certificates because we are in the process of trying to figure out ways that we can be in your home safely during lockdown. But if you're interested in either of these, do let us know, and we will make sure we get back in touch once we've figured out how we can get into homes safely during COVID lockdown. Another aspect of our work is retrofit coordination. And what that means is supporting you through every step of the way, making sure that if you're doing a big project where you've got sort of over £10,000 that you're looking to invest in your home and make it more energy efficient, you can really make the most of your money, because you'll have someone that's qualified and assigned to your project to help you through every step of the way. And we work with an organisation called EcoFurb on that. So if you're doing a lot of work to your home, do drop me an email and I'll tell you a bit more about that. And the last part of our work is our webinars and workshops, just like this one. And as I mentioned earlier, you can find our old webinars on our website at futurefithomes.org/blogs. And you can also find a lot of free information on that blog, such as the basics about the Green Homes Grant and a few other tips and tricks, which we're constantly updating. So the website is futurefithomes.org. And you can find out all the information on there, or just drop us an email. So just a little bit about Celsie and who we are really. Celsie came together because a group of local residents in Greenwich and Lewisham had one vision that they wanted for the future. And that vision was to create a low carbon future where everyone has access to affordable energy and has a voice in how it's produced. So we're very much focused around engaging people in energy and making sure that no one's left behind. We were formed in 2014 and we're registered as a community benefit society with a co-op structure. So all of our members have a say in how we're run. We've had some wonderful volunteers in our time, and we've actually racked up over 10,000 volunteering hours, which is amazing. And we've stopped counting now because it's gotten so high. So we're really grateful to all our volunteers. What kind of work does Celsie do outside of Futurefit homes? Well, we help organisations install solar PV and LED lights. And these can be organisations like schools, leisure centres and community hubs. The great thing is Celsie and our investors can fund all of the upfront costs of the work so that the sites, who are often quite strapped for cash, only have to pay back on a month-by-month basis while they're saving money on their energy bills. The second part of our work, and probably the biggest, especially this winter, is giving out free and impartial energy advice to people in fuel poverty. So that involves things like helping them find the right tariff, negotiating with the energy suppliers and making sure that the suppliers are actually telling them the right things and keeping within the law. Delivering light measures, so that means things like radiator reflectors and draft excluders, and helping people apply for funding where it's needed. So helping them get a new boiler maybe, or discounts on their bills, which they wouldn't have access to without our assistance. But that's enough from us. I would like to get straight into the presentation on heat pumps, and I would love to welcome our director and energy engineer at ISO Energy, Jason Blanchard. Jason has a master's in renewable energy engineering, and he's also supported lots of community energy groups across the UK, which is what won him the award of Community Energy Young Champion in 2018. So without further ado, I will pass on to Jason and let him share his slides.
Thank you, Nadia. Let me just see if I can get this set up. Cool. 3 years ago that award was. You are making me feel old. So it is great to see everyone online tonight. So many people excited about heat pumps and finding out a little bit more about them. Hopefully after my sort of short overview tonight, you'll go away and all sort of research a bit more and really sort of consider it as a technology for your homes yourselves. So Nadia really gave me all the introduction I deserve, but very, very brief overview of me. Obviously a non-exec director for South East London Community Energy. And my sort of day-to-day job is mixed technology consultant for ISO Energy, doing a lot of work with heat pumps, solar PV, increasingly EV chargers and batteries, but also biomass, solar thermal, and many other technologies. My background is sort of in community energy, and that sort of remains my passion, working with Celsie and many other groups across the country still. So the question that everyone is probably asking themselves today, why heat pumps? Well, firstly, the environment. We are in the middle of a climate crisis. As Nadia says, 22% of the emissions come from homes. And quite a large amount of those emissions are heat. We are obviously looking as a country and indeed as a world that electrifying heat is one of the key ways to reduce that carbon footprint. And indeed, with heat pumps specifically, you can achieve carbon reductions up to 75%. So it's very worth doing. Fuel savings, well, everyone wants to reduce their bills, especially at a time that we currently find ourselves in. So on an ongoing basis, a heat pump that's well designed and well installed could save you, 40 to 50% of your bill against your heating and domestic hot water supply at the moment. Financial support. Well, the government are very much in favour of this as a technology, air source, ground source, along with other technologies. They're really pushing at the moment. I'm sure many of you, if you're on this webinar, will have heard about the Green Homes grant. We also have the Domestic Renewable Heat Incentive, which is still available for heat pumps. There's been a lot of talk about the Clean Heat grant, nothing confirmed as yet, as far as I'm aware, but perhaps some of the other speakers could pick up a bit on that idea. And then some notes at the bottom, the non-domestic renewable heat incentive was a scheme that's unfortunately leaving us fairly shortly, and public sector decarbonisation scheme, which many people may know as the SALEX funding for sort of the larger public sector buildings, etc. So running costs, well, that's one of the key benefits of heat pumps. These, I have to admit, this slide is probably a little bit out of date now, but it just shows that these prices do change quite regularly. So going from left to right there, you've got electricity, which is shown at about 12p. Actually, the average is probably closer to 13 now. Your fuel oil about 6.5, and LPG around the same. That's very volatile because they're directly linked to the oil price. Your wood pellets are, obviously in green as a renewable source, and you then, moving on to your natural gas at 4.5p, which is what many of us are using in the UK at the moment. That actually is probably a bit high. Those prices have dropped. We're seeing, 3.5p sort of commonly at the moment, which puts it far more in line with air source, which will be somewhere between 3.5, 4p. Your wood chip, fairly similar, but actually that price is quite volatile as well, and we're seeing a lot more wood chip actually being shipped in rather than sourced locally, so there are environmental questions over that. But the fundamental is a ground source heat pump, an air source heat pump. These are still some of the cheapest ways to provide heating and domestic hot water services to a property on an ongoing basis. So heat pumps, what do? They are not just a magic box. Lots of people want to think they're just a magic box, and for a lot of people, they don't necessarily need to know much more than, yes, they provide heating and hot water, and they look a bit like a fridge freezer. But what they do very simply is they take energy from the environment, be that the air around us, be that the ground, be that water. They take usable heat out of the ground, they compress it to make that temperature sort of rise, and then once it's up to a usable temperature, it's then used for your spatial heating and your domestic hot water supplies. Heat pumps obviously do use electricity, so it is very important to make sure you're on top of your electricity price. As I think Nadia was mentioning, this is a sort of joint solution. You need to look at insulation, you need to look at your electricity price. But for every unit of heat that a heat pump will use in electricity, you should be getting 3 to 4 as a rule of thumb of usable heat out of that heat pump, depending on the technology. So air source heat pumps. Air source heat pumps sometimes get a bit of a bad name from feedback we get in the industry, and I think we definitely need to dispel that. It's the same technology as ground source. It's exactly the same cycle going on. It's exactly the same, similar piece of kit. What is going on is simply they are slightly less efficient. And the reason they are slightly less efficient is because rather than taking energy out of a constant source of temperature, like the ground, which doesn't actually vary in temperature too much over the year, or water, which is constantly replenished with energy, so ground source heat pumps, air temperature changes drastically, as I'm sure if you've been outside today, you will be aware. So it's about sizing them correctly and accepting that actually they won't be as efficient as a ground source year round, but if sized correctly, they can be quite close to just as good as ground source at a significantly lower cost. Just to sort of outline that in a sort of very clear way, ground source heat pump, COP, which stands for coefficient of performance, which is your heat pump efficiency. Very simply, your ground source heat pump will be looking at around 4 units of heat out. So your 3 that are from your heat source or the environment, and your 1 that is electricity. An air source, we're looking at around 3 to 1 around the year, and that is 1 unit of electricity for every 3 units out. These are very much rules of thumb, and indeed an air source will vary its efficiency year round. Higher air temperature in the summer means that air source will be running far more efficient. Equally, in the summer, you're not doing much heating for the home, so your air source is just focusing on hot water, which makes it more efficient also. So these things all play into the efficiency of a system, and whilst an air source and a ground source we can give rules of thumb, it very much is dependent on the installation, the time of year, and what sort of heating and domestic hot water and other services it's providing. So what do the systems look like? Well, very simply, an air source will be a large heat exchanger outside with a fan. Looks quite similar to an air conditioning unit, but an air source will usually be quite a bit bigger than an air conditioning unit, largely because it needs a larger heat exchanger, and that needs to be quite large to capture as much air hitting it as possible, take as much heat out as possible. For smaller installations, we could use a single unit, as we can see over here, which can provide your heating and domestic hot water services. For larger units and larger installations, maybe multiple air source units outside, you will need a 2 tanks, your domestic hot water tank, and also a heating buffer tank. For a ground source heat pump, there's a few more options. We'll go into that in a bit more detail later, but you have your collector, be it from the ground or from the water. You have the connections back to a manifold or multiple manifolds, depending on the size of the system. And then you have a single flow and return back to your plant room, which can look a lot prettier than this. We obviously, hopefully, our pipe work is actually improving the visuals there. They clearly did not want to plaster that wall or do anything useful there. But you have your heat pump and you have a couple of tanks on this side, as well as some expansion vessels. So plant room space is a consideration far more with ground source than it is with air source, which we'll come on to later on. So running along those lines and those considerations to think about, a ground source heat pump, you really do need to consider things like your electricity supply. And I know Verona will be going through later about upgrading electricity supplies, etc. And I will briefly cover where that might be applicable. You need to consider your heat source. So are you going to be using water? Are you going to be using the ground? And exactly how are you getting that heat out of the ground or the water? You need to consider plant room space. As I'll go through later, some plant rooms do require quite a bit of space. They don't always have to be in the house or in the flat, but you need to find that space somewhere. So they can be in external sheds or located in a basement or something like that, but you do need to have space available. And your heat emitters. This is always a question that comes up in our office, and very, very quickly to start, no, you do not need underfloor heating for a heat pump system to work. And that is one of the most common questions that we address. It is simply about having sufficient heat emitter, be that radiators, whatever type they are, underfloor heating, air fan coil units, whatever your heating system that you're going to be using. If it's a wet system, is what I'm largely focusing on today, then you may have to adjust it, but actually in a great deal of cases that we find with installs, you don't require a great deal of adjustment to your heating system. Air source, again, similar considerations. Electricity supply becomes far more of a consideration with air source because they are a little bit less efficient, and we'll talk a bit more about that later. Plant room space becomes slightly less of a concern than with ground source, because of course you have your air source unit sitting outside. Unit sizing is the most key thing, and understanding that an air source heat pump that is rated at 12 kilowatts is actually rated at probably +7 degree air temperature outside. That is not necessarily when we care about how much usable heat that air source can provide you. In the UK, we want to understand what that heat pump can provide you at -7 degrees, or perhaps even lower. We've certainly been having a lot of snow lately, so I know a lot of people, certainly up in Scotland, will be arguing quite a bit lower than that. As the air temperature drops outside with air source heat pumps, they get less efficient and they're able to provide less heat and hot water to your home. So unit sizing is one thing that I will really reiterate throughout this presentation. Planning permission, obviously you have to consider, which actually is far more of a concern to people before they stand next to an air source heat pump and realise that actually they really don't make a lot of noise at all. Heat emitters, same basic principle that we went through with the ground source. So plant room space, how much space do we need? Well, for smaller units, for smaller installations, we can hopefully get away with a single unit inside. Now, these are sort of fridge freezer, so they're sort of 2.1, 2.2 meters tall. They're quite tall units, but it is a single unit that can provide your heating and hot water. If you connect it to an air source, then that air source will obviously be located outside. This is a 22 kilowatts inverter driven heat pump. And as you can see, we have a 500 litre tank and a 100 litre heating buffer tank with some expansion cylinders. Again, there you can see we've kind of got probably 2.5 meters by about 1.5 meter in depth. 68 kilowatts, we're starting to get bigger now. You will need 2 heat pumps, so quite a bit bigger size. And the tanks get quite a lot bigger. These are 800 litre tanks, and we take up far more room at that point. 102 kilowatts, as you can see, these continue to get large until they get into fairly sizable and, you know, commercial in a lot of cases. So electricity supply, this is something that I mentioned earlier as a consideration. I know Rona will go through this in a lot more detail than I have, but I just wanted to give you some very rough rules of thumb. Single phase supply, how can you identify it? Well, you'll have one of these blocks sitting there, and your supply will look something like this with your main meter there. 3-phase supply, well, you'll have 3 of those blocks, and they'll sit there again beneath the meter. Most people in the UK will have a single phase supply, and the majority of domestic homes will have 100 amp single phase supply, which will be denoted by a sticker, or potentially on the older ones, sort of plastic engraving of 100 amps on the breaker. These are very much rules of thumb, and I know that Rona will probably go through a bit more detail, but the limitations of your supply, if you have a single phase supply, you're looking at up to around a 30 kilowatt heat load for a ground source and around a 16 kilowatt heat load for an air source heat pump on 100 amp sort of domestic supply. 3-phase supply, well, the sky is kind of the limit. It depends very much on your ampage at that point, but majority of heat pumps will run quite comfortably off of 100 amp 3-phase supply. Collector type and size. So I promised I'd go through this in a bit more detail, so let's explore the different types. Horizontal. So this is where we dig trenches, and they're 1 meter wide, 1 meter deep, and you lay pipe down one side and back the other. Now, the important thing to understand here is there is a certain amount of energy that you can take out of the ground without affecting that ground permanently. What we need to avoid at all costs is slinking the pipe or overlapping the pipe to a point where the ground cannot recover, to the point where you take more than a couple of degrees out in the winter, because at that point, it may not be a problem in the first year, it may not be a problem in the second year, but 3 to 5 years in, you will end up with a field of permafrost, which we have come across more than once, unfortunately, not from ourselves, but from other installers. And what is key and what we have decided is actually you definitely need to not slinky the pipe in the ground and actually maintain that thermal separation to ensure that you're just not taking that much heat out of the ground. So how much land do I need if I'm looking at a ground source? Well, it depends on the type of collector, but I've given some very rough rule of thumb figures. Trench lengths, we usually do 50 to 150 meters, which is of course going up one side and back down the other, 100 to 300 meter loops. Across the UK, the very rough figure for a horizontal trench, 1 meter down, is you can safely extract. So 100 meter trench, 200 meters of pipe, 3 kilowatts. To put that into context for you, 200 meters squared, 1960s average house, average insulation for that period, glazing, etc., probably around 12 kilowatts. You'd need 4 100 meter trenches to satisfy that load. So you are talking about a fair portion of land. Alternatively, there is vertical, which we'll explain a little bit more later on, but 3 boreholes at 110 meters deep. Boreholes, I know that the sort of phrase borehole seems to scare a lot of people. They think of these huge gaping holes that are never ending. They're actually about 6 inches in diameter, and they need to be 10 meters apart for that thermal separation again. So just as a example to the extreme, quite a large property here, quite a large old property here. We're looking at 110 kilowatt load. That property down the bottom there, and what we are considering and what was installed was that. So you can see in relation to the property, the space required for the collector. Boreholes, however, quite a bit less space. So you have much more of a space saving opportunity here. They're about 10 meters apart, as we can see here, and they lead back to the manifold and back into the plant room. Actually, when all is done and all the mess is over, all you actually see once all the drilling is done are these 2 pipes sticking out the ground, which we then connect to a manifold and are then buried themselves. So you don't see anything other than the manifold, which indeed can be covered over itself also. But there's no escaping that if you are considering boreholes, you will have to deal with one of these monsters turning up on your doorstep. They are quite loud, they are quite messy. The important thing is it is temporary. It is very temporary. Even in the worst conditions, it's usually around 1 borehole a day for one of these, and it is very rare that it takes, that a property would have to be quite a size to take more than 4 or 5 boreholes. Lake collector. Now, the more observant of you in the audience will be shouting at me, you've just lectured us, literally just a moment ago, on not slinking the pipe. Well, yes, and you're correct. You should not slinky the pipe when you put it in the ground. However, in the water, the energy is constantly replenishing with the flow of the water. So the water drops its temperature, but it's constantly moving and replenishing, unlike the ground. So in the water, it is perfectly sensible to slinky the pipe. Again, you don't want to overlap them too much, but depending on the body of water, you can you can definitely slinky the pipe safely. The bottom left there, I actually helped install that, and I took that photo, so I'm very proud of that. Now, a more recent development and newer technology are energy blades. Now, energy blades have come into the market in the last 4 or 5 years, I believe. They are effectively plate heat exchangers or radiators running in reverse. They are taking energy out of the water as it passes through them. There are no moving parts, and then they are providing that energy back to the heat pump. As you can see here, you can install them along a riverbank, cover them over with a decking, and you'll never even notice they're there. So this is quite a neat solution if there is running water present. The costs. Now, obviously, we get down to brass tacks and what a lot of people want to know. What I would say is there is a huge variance in the industry. And what I have tried to accomplish here is to give rough ranges to show what we are seeing in the market for a normal size property and a normal quality install with normal quality kit, sort of averaging everything. But there is a huge range, and it very much depends on your unique circumstances, what heating fuel you're on, what your distribution system in the house is, radiators, underfloor, how far away your heat pump is from where your boiler currently is, and so many more factors play into the costs of these systems. But I've tried to provide some figures to give some idea of the ballparks that we are talking. So, if I can leave you with anything, and I assume by now you want me to leave you because you're probably quite bored, sizing is crucial. And that means sizing the heat pump, sizing the collector, sizing the buffer tank, the domestic hot water tank. Everything comes down to sizing the system efficiently and effectively. The quality of kit in the market does vary, and you do need to make sure that you're going with a trusted manufacturer, a trusted installer, but it is vital that the design of the system is the most important thing. And what happens when it goes wrong? Well, we've looked at this one in the bottom right here. What happens if you incorrectly size or under design or undersize a ground source horizontal loop? Actually, you can also freeze manifolds with this problem. Air source heat pumps, if they are undersized or incorrectly installed, can become quite expensive blocks of ice for you. And indeed, in extreme situations, the compressors can effectively break completely. And this was quite a catastrophic failure due to an air source being significantly undersized. And I mean half the size it should have been. So that's all from me for now. I may well have churned up a load of questions in you, so please obviously hold those until the end of the webinar, and hopefully we'll be able to answer some of those for you. My contact details are there, and obviously the slides will be made available as well. So if there's any questions at a later date, please feel free to contact myself. And hopefully you know a bit more about heat pumps now, and you can go away and really explore whether a heat pump is right for your property. Thank you. I'll pass you back to Nadia then.
Thank you so much, Jason. That was really, really helpful, really insightful. And we have actually got quite a few good questions coming out of there. But we will hold those just until we've finished Rona's presentation as well on upgrading your fuse. If I could just ask you to stop sharing your screen, if that's all right, Jason. So, lots of questions coming up. But before we get to all of your questions, I would like to ask you guys a few questions as well. So you might see a poll come up in a few minutes, and we've got a few questions on there. So please just let us know what sort of areas it is that you're interested in, why you're looking at heat pumps. You know, if I just run through the questions, and let me know if in the chat if you can't see these questions. They should be on your screen right about now. You might have to have upgraded to the latest version of Zoom to be able to see the poll questions. But we've got sort of, what is your existing heating system in the home that you're looking at a heat pump for? Have you got a thermostat at home? Where is your building insulated? If it's insulated quite well, what areas have you done already and what areas have you got left? And then, have you got any other renewable energy tech installed? Quite often, people that are interested in heat pumps, I think it's fair to say, have been interested in renewable energy for a little while. Have you ever switched energy suppliers? Have you ever changed tariffs or tried to get the best deal that you can out there? What kind of energy tariffs you're on, if anyone uses a time of use tariff. So that's a bit like economy 7. It means that you're charged different rates at different times of the day. And we'll go on in a little bit to why those tariffs are quite interesting, probably. Have you got a smart meter? I would hope that a lot of people have already got a smart meter, but it's looking like it's about 50-50 at the minute. Whereabouts you're based, and someone was asking earlier where we can actually offer services. So Celsie is focused mainly on Southeast London, and we can offer all of our services that are in the home to boroughs in Southeast London. So that's Greenwich, Lewisham, Bexley, Southwark in some cases, and Bromley. But if you're outside Southeast London, we can still offer you advice over the phone or over a video call. What is the main reason that you're interested in heat pumps? Is it bills or is it carbon emissions? And the final question is, are you going to be looking at using a government subsidy for any of this work that you're getting done? So as correctly highlighted in the chat, there is a button right at the bottom to submit your answers, and I can see most people have put in their answers now. So just do let me know in the chat when you've done putting in your answers. Right, really, really interesting areas, really interesting. Quite a range of different answers on here, so that's really good to see. Right, lovely. So people are almost finished with their answers. We'll give you guys a few more minutes just to finish off. It's always interesting for us to find out as well what sort of brought people to this space, because you would assume that, you know, most people want to reduce their bills or want to reduce their carbon emissions, but quite often it's a number of different things that come into play when you're thinking about these technologies. So if there's any questions that you can't answer, don't worry about them too much. It's just to get a rough idea about things. So we'll just wait for a few more people to answer before I share the answers. Wonderful. So we're getting there. We're getting there. I'm seeing more and more questions come in. Jason and Rona, you're going to have a bit of a task on your hands. All right, lovely. So I'm going to close off the polling now. So if you're doing the questions, do just finish off and submit so I can share the results with everyone. Okay. So we can see that most people here already have gas central heating. And then a number of people also are using electric heating. So that's really interesting to see. A few people have also got solar thermal, wonderful. And then it's split between everyone else as to what other systems you've got. Most people have got a thermostat in one room. Okay, great. And we've got 18% already have smart heating controls. So that is interesting to see. And there we go, 61%, as I expected. You've got loft insulation already. Well done. That is the first win on insulation. Big number of you haven't got any insulation at all though. So that's definitely something to think about before you get a heat pump installed. And just something to think about generally when you're trying to reduce your emissions. As someone mentioned in the chat, we use this term in the industry called fabric first, and that means making sure that the building fabric, or what your house is built with, is as efficient as possible before you start adding more stuff into it. Quite a few of you have not got any other renewable energy tech installed, 65%. That's amazing to see. But most people either have solar PV or solar thermal already, and a few of you have electric vehicles. Great. Wonderful. We've got a lot of people who have switched energy supplier more than once. 54%, that is very exciting to see. And quite a few of you have switched before. If you haven't switched, do look into it, because you're probably not on the best tariff. So there are comparison websites that you can have a look at. Most people not on a time of use tariff, as I would expect. And some of you are on an economy 7 or a similar tariff. And some people don't know what time of use tariff is. So as I mentioned earlier, essentially means that the electricity or the energy you use is charged by the time of day. And that is because at certain times of the day, it's a lot cheaper to make electricity or generate electricity. And that's going to increase in the future, because we're going to see a lot more renewable energy come online. So you can't choose when you generate renewable energy. It's really down to the wind or the sun. Wonderful. About 44% of you have a smart meter, and another 40% don't have a smart meter but want to get one. That's great to see. 15% don't have one and don't want one. I would really be interested to hear why you don't want one. There are quite a few misconceptions about smart meters, so definitely have a look at the Energy Savings Trust website for some accurate information on that. And most people in Southeast London, a few people outside of London as well, welcome. Main reason people are interested in heat pumps is for carbon emissions. Thank you, everyone here. You've got your heart in the right place. And then the second option is saving on your energy bills. And finally, about 40% of people are thinking of using the Green Homes Grant or the Renewable Heat Incentive. But there is another 20% that either think the wait time for the Green Homes Grant is a bit too long, or they don't feel that they need a subsidy. So really interesting on that one, guys. Thank you so much for taking part in that. And we're now going to head straight into Rona's presentation. And it's really wonderful to have her join us. So I will just share my slides with you. So Rona is from UK Power Networks, and UK Power Networks are the electricity distributor for London and Southeast England. So there's a number of electricity distributors around the country, and UKPN is the one that we've got here. What they do is manage the cables in the ground and make sure that we have safe and reliable access to energy, and that it doesn't get too expensive as well. She is the Innovations Project Lead, and she works on heat. And she's currently working across predicting faults, where they might happen and where they might come up, network flexibility, which I'm sure she'll tell you a little bit more about, and the future of heat. Rona's got a master's in engineering from the University of Oxford, and she's really focused around marrying together engineering and sustainability to create a low carbon future. So using different tech together in a way that makes it efficient to get to a low carbon future, and making sure they all work together in a smart city system as well. So thanks for joining us, Rona. I'm going to stop sharing my screen now and pass over to you so you can start sharing.
Thanks, Nadia. I think I jumped the gun and tried to share earlier, so sorry about that. Thanks
No
for the really
worries.
kind introduction. Hopefully, can you see it, the big orange blob?
Yes, we've got it. Wonderful.
Excellent. Okay. So hello, everyone. Thank you very much for having me. And I know it's been said a couple of times, I'm going to talk to you all about upgrading your fuse. But what I'm actually going to do is give you the knowledge a little bit to learn more about the electricity system, so that you can kind of do some more self-assessment, because I find with a lot of these things, you know, renovation, low carbon heating, it's really hard to even know where to start sometimes. So I'm going to kind of start with the building blocks and a bit of an introduction to what UK Power Networks is, what is important to us, and then I'm going to touch on the fuse upgrade at the end. But hopefully that in and of itself will be kind of a small part of the overall session. So as Nadia said, UK Power Networks looks after the east and the southeast of England, including London. If you live in some parts of West London, we might not cover you. We kind of go about as west as Acton. And there are 6 different network companies across the UK, but we're all very similar and we're all regulated by Ofgem. UK Power Networks looks, our rule of thumb is whatever the UK total is, we normally cover about a third. So we've got 8.3 million homes and businesses. We actually have a lot of distributed generation connected, and that is a mix of renewables as well as non-renewables, but things that are too small to be connected at the transmission level. So not really giant power plants, more smaller things. And our peak demand is about a third of UK total as well. And although, you know, we used to be government owned in the early 90s is when they privatized the electricity networks, we have a really interesting regulation framework with Ofgem where they really incentivize us to make sure that we work really closely with stakeholders to meet their needs and evolve and do what our communities need us to be doing. So that is a really, really, really big part of everything that we do. And an increasing area around this has been the move to low carbon. Now we have the new vernacular of net zero because we have the legal target for it. And so the history of that is we first saw the feed-in tariffs really spark generation on our networks. So on our high voltage networks, we have over 8.3 gigawatts of distributed generation connected. And actually it's doubled in the last 10 years. So everything that we had up until 2011, we've doubled since then. And we have a huge amount that's now actually accepted or in delivery. And we have over 170,000 smaller connected generators. So that can be people who have solar panels on their house or other things. There's also a lot going on with energy storage, so batteries, domestic batteries as well as really big batteries. We built at the time the biggest battery in Europe, Leighton Buzzard, which we called the Big Battery. And there's now a lot of other stuff in that area. And then I've put them in the wrong order because what happened next is we saw a lot around the network around electric vehicle growth and what that's going to mean for us. And right now we have over 30,000 charge points on the network, and we expect that there's going to be over 4 million electric vehicles charging on our networks from 2030. And then the next really interesting space, I've been working on this for about the last year, is heat decarbonization. But obviously from an electricity network point of view, we're very interested in heat electrification because that's what we need to facilitate. And there's lots of interesting things in this space. The future home standard is likely to come in from 2025, although there's some changes coming in from 2023, which will mean that all new build homes will very, very likely be heated by electricity. We think we have around 27,000 100,000 heat pumps connected to the network today, but that's going to go up by more than a factor of 10 by 2030. So it's an interesting time to be working for an electricity network. So don't be scared by this slide. The purpose of this is to explain a little bit how the network works and why things like flexibility are so important. Because I know that's not the purpose of today, but we hear about it more and more. Smart local energy systems, people being flexible. And for the managing the overall supply and demand of electricity in the UK, for example, when it's really sunny and really windy, you would want to use more energy, turn on your washing machine or charge your electric vehicle when there's a lot of generation. That's really, really important. But what's also really important is looking at the capacity of your local network. So what we see here on the screen is an approximation to how the energy network works. So the houses where you are, or down at the bottom of the slide, are all connecting at low voltage. And then as you go up the network, they're at, the network configuration is we have different feeder groups. So the ones that are all the same color are all together. And what this means, for example, is if on the left, the homes in the neighborhood where the blue dots are, if everyone there gets a heat pump and electric vehicles, that could put some constraint on the cables in that area. So we would need to manage that. And being able to potentially reconfigure the network. So if some of those light blues could actually be part of the light green feeder group, those are the types of clever things that we are working on. I think I'm going to move on from there, but happy to come back to it and answer questions if that's piqued anyone's interest. And then a slightly less technical network overview is to kind of start from the highest level of voltage, which is the transmission network, which is looked after by National Grid. And they have their big towers. With lockdown, you're probably not doing as many journeys and travels, but you quite often see the big towers along the motorways. And for every grid supply point, they would then step down to a slightly lower voltage, but still very high, which is called a bulk supply point. And so one grid supply point would feed 6 bulk supply points. And then this is into what the distribution network looks after. We would then have the primary substations at 33,000 volts, and you'd get sort of 6 primary substations fed from a bulk supply point. That would then go to a secondary substation, and those are the local ones, the little kind of boxes that you see around your walks. I've got a picture of one coming up in a minute, and you'd have about 20 secondary substations fed from a primary, which would then feed between 100 and 200 homes. I have pinched this from the very, very good book, GB Electricity for Dummies from CGI. So if you're interested, please go have a look. And this is my favorite picture explaining what the electricity network is like. So these are substations, secondary substations that you might see. And all those little open points you saw on the more technical diagram, these link boxes in the middle of the screen, that's what you would see under a pavement cover. And that is basically how we manage the network. We'll have switches within the secondary substation, and then we also have the opportunity to reconfigure the network from the link boxes. And like what we heard earlier about the 3-phase supply, if you're not super familiar with alternating current and the fact that there's 3 phases, don't worry about it. Not everyone has to be experts in electricity, but the electricity network has 3 phases, and traditionally you could call them phase 1, 2, and 3, but we quite often use red, yellow, blue. And that's another interesting area around making sure the network is balanced. So most homes and most electric vehicle chargers will be on 1 phase. And it's a little bit random when, homes were connected to the electricity grid when they were built at any point over the last 60 years. Before that time, it's not guaranteed. Well, I don't know how many, maybe more than 75 years ago, there might have been homes that weren't originally connected to the grid. So that's a bit of explanation about the grid. And then the reason this is important is the more people who have heat pumps means that their electricity usage will go up, which means that the cables and the wires feeding the houses, if everyone in a street overnight got a heat pump, that could be a problem for us. And it's our job to reinforce the network or work and use flexibility services to basically make sure the network runs smoothly all the time. And what can sometimes happen, especially in old houses, is the fuse in the box that comes into your house might be a really low rating because when your house was perhaps built, it would have had a few electric lights and nothing else. And then over time, we've upgraded to have microwaves and fan-assisted ovens and fridges and computers and whatever else. So normally the cable coming into your house is big enough to supply a heat pump, but sometimes the fuse needs to be upgraded. And there's a broader system to make sure that we know about heat pumps. And it's a UK-wide heat pump process. And I was just going to step you through it a little bit. We've got a dedicated page on our website which explains all of it. And from the heat pump page, if you kind of follow through and see if you think you might need a fuse upgrade, we've got some dedicated advice around that and what you might need to look for. In general, the installer and the electrician coming to your house, they will be doing that assessment. And in many cases, they can arrange for it to happen, and you might not even really know that someone from the electricity network has been around to do that upgrade. It's very different with different installers and different types of things, but we are very happy for installers to carry out the notification process on behalf of the customers as long as they've had the right permission. The fuse upgrades are free for those who need it, and it all links back to the blanket. The Energy Networks Association is the voice of all the networks in the UK. So it's a standard process that we have agreed on that works best for everyone. And I'm not going to lie, some of their forms are very technical and not very nice to read. But we're always doing our best to improve things and make things better. And then the NA process is reflected in our documentation. I think that's pretty much all I had to say about this. So there's a little bit of this diagram here I've reproduced from our fuse upgrade page. There are some things to be aware of, especially if you're looking to get quite a large heat pump or perhaps a 3-phase heat pump. You would need to upgrade your supply to 3-phase. That would be chargeable work. And there's also a possibility that if your house is quite old, if the cables, it might not even be the cable coming into your house. It might be the cable between the large cutout box and your electricity meter, which are known as the tails. Those might need to be upgraded. So there's possibly some more involved work, but we do it all the time for lots of different customers. It's just something to be aware of. And we are also, at the moment, trying to promote our fuse upgrade service to people who are thinking about getting a heat pump in the future. It is free to do, and then you know that your house is ready for when the time comes. Or if you request a fuse upgrade and then you possibly find out that your meter tails were a bit small, that's the sort of thing that could, you could get sorted out in advance, and then when it does come time to get the heat pump, it can be done very quickly. We have a broader heat strategy about what we're doing to be ready to support the electrification of heat where that works for people. And we've recently published some guidance. We called them our heat packs to give a bit more of a broader understanding of heat decarbonization. I think in the audience today, I've got a pretty well-informed audience. So it's probably not, after sitting through this presentation, it's not going to have too much more stuff that you don't know, but it still might be of interest.
Yeah, so the link to the heat packs is actually in the chat as well, Rona. So anyone who wants to make sense of all of the techie stuff, the heat packs are the place to head to. But yeah, we have sort of 2 minutes left, if that's all right.
Yeah, I think this might be pretty much it, actually. What I was going to say, though, to everyone is that I'm just coming to the end of a project called Heat Street, where we've done some more detailed modeling and forecasting to look at housing archetypes, what kind of houses are in our geographical area, to try and work out where do we expect that there will be more heat electrification, and therefore where we need to prioritize monitoring the network more, potentially looking at more flexibility services and maybe even some reinforcement projects. And we're sharing all that on Thursday, 25th of February at 2 o'clock. It's on Zoom. You're invited. And then my email's there at the bottom. If you wanted to get in touch about anything else, please feel free. And with that, I think I'll stop sharing. And I've seen the little orange box. So I think that means
that's
lots of
wonderful.
questions.
Thank you very much, Verona. Really, really appreciated. I know that I definitely feel out of my depth when we come to talk about this kind of thing, but I think those diagrams were really helpful in terms of just, you know, making sense of what are the cables under the ground and what do they actually mean for us, for the people that just want to install this kind of tech in our homes. So yeah, really appreciate it. There are a lot of questions I can see. So let's get straight into it. Carol is asking, can you put an air source heat pump on the wall? Does it have to be on the ground?
So in general, there needs to be some space behind the air source heat pump. Now, the reason for that is air source heat pumps effectively work by sucking the air in through the back. So you need a clear intake and then expelling the colder air out the front. So generally we ground mount them or roof mount them. You can mount them, but they need to be open to the atmosphere because that's where it's getting its heat from. So mounting against the wall, obviously technically feasible as long as you have a mounting bracket, but actually not very efficient. And yeah, not a great idea.
Okay, that's really good to know. Right. So the second question from Jamie was asking, what are the sort of space requirements? I mean, is it ideal to try and install a heat pump in a small terraced house, like a terraced house with a small garden? Would a borehole be the right way to go in this scenario?
A borehole, probably not, because you have to think about, we had a look at the drilling rig in my presentation. You do have to think about how you would get one of those monsters in a back garden or a front porch or whatever it may be. Smaller properties, inherently, usually air source is the better option because they are a much more of a space-saving option. And indeed, the mobilisation costs of boreholes, actually getting the drilling rig there, are very high. So for smaller heat loads, air sources are far more economical as well.
Okay, wonderful. And so we have got Jonathan who's asking, you know, are air source heat pumps really that effective in winter?
So this comes back to my favourite part of the presentation. Sizing is everything. It's making certain that if you've got a 12 kilowatt heat load, you may need a 20 kilowatt air source heat pump because that 20 kilowatts is at +7. And at -7, that 20 kilowatt heat pump is probably only giving you 14 kilowatts. So they are effective as long as they are correctly sized. And we have numerous, you know, hundreds and hundreds, thousands, I would say, probably, of these things now sitting in people's gardens, on people's roofs, happily, you know, running and providing heating, hot water, swimming pool heating, cooling, a number of services to properties quite comfortably.
Okay, so you can put them on roofs. That was one of the questions, actually. So that's good to know.
Smaller ones you can put on roofs. They are very heavy units.
Okay, cool. Paul is asking, is a 16 kilowatt heat pump big enough for most people's homes, the average home?
I mean, I think the majority of the presenters would agree with me, as you probably would, Nadia, that there is no such thing as an average home. But I would say, I mean, an average heat load in the country for a house, as we were kind of looking at 1960s, 200 meters squared is kind of an average house, I would say, and I'm speaking in very broad terms here. But, you know, you're probably looking at somewhere around a 12 to 15 kilowatt load. Flats are obviously quite a bit less. Bigger houses, as I sort of showed my extreme example, can be 110 kilowatts, you know, but air source wise, yes, I would hope 16 kilowatts air source would cover the majority of homes. Ground, but the larger ones you do need to go to sort of larger installs, definitely.
Okay, wonderful. And so obviously working out heat loss calculations is a big part of understanding how to size the system. And I know that some people here are a bit more techie and want to do a lot of stuff themselves. Patrick is asking, is there any open source software? And maybe this is a question that some of the other speakers might know the answers to as well. Is there any open source software that makes doing heat load calculations a bit easier and simpler?
I suspect that might be one for Richard if he's listening in.
Yeah, I am. Sorry if you can't see me. I might have disappeared off people's screens. Yeah, I'm aware of one software. I'll have to find it and I'll put it in the chat when I found it. And you pay per survey basically. So you probably get the first one free, but you'd need to know the size of each room and all characteristics and roof characteristics and that sort of thing. I'll find it and pop it in the chat. That's the one. It's just gone in there. Heat engineer.
There we go. We've got a team of experts in the chat today. And there is also a Facebook group that I've posted on there called Heat Pumps UK and Ireland. And that has been hugely helpful for me personally to find out more about heat pumps. So do check it out if you're on Facebook as well. Andrew is asking, to do with the noise, it's really hard for us to understand what 50 dB actually sounds like. What is it as loud as? Is it as loud as a fridge or?
Yeah, so this is a difficult one. The MCS, which is Micro Generation Certification Scheme, which is sort of the governing body for most small scale renewables, are very strict on noise. We can't raise the background ambient noise by more than 1 decibel with one of these things. So the units have to conform to a reasonable noise characteristic. The practicality of that is most of the time you're not going to hear them at all. In the depths of winter, when they are running flat out, you might hear a slight sort of noise as the compressor goes, but it's no more than hearing someone in a flat 3 doors down, you know, with a Hoover. In the early days of air sources, yes, they were pretty loud. That has moved away in the industry, and the new generation of air sources are much quieter now.
Okay, that's really good to know. And so Charles is asking, can you use the exhaust from a mechanical ventilation heat recovery system to increase the efficiency of a heat pump?
That is a technical question. MVHR exhaust into an air source. Okay.
Yeah.
Yes, I don't see why not. If you are expelling heat, but a lot of the time you're actually using that MVHR to heat the home itself. You're expelling heat back into the house. So to then run that through a heat pump potentially has some merits. It might be an interesting study to look at. But in general, you would probably throw that heat into the home directly because your air source would be sitting outside and you probably don't want to throw that usable heat outside.
That's an interesting point. Okay. So we are actually running out of time for questions, so we'll just do one more. But if we didn't manage to catch your question, please do drop it to me via email. My email is nadia@celsie.org.uk, and I'll try and send it out to the speakers and get you a response on that after the webinar as well. But last question from Chris. He's saying that we know that the Green Home Grants payments have been quite late, and a lot of installers have struggled with the lateness of those payments. Do you think it's risky to put a deposit with an installer if you're planning to use the Green Homes Grant? Should you just wait a little bit until we find out how it's going to smooth out? This is probably a question for everyone again, isn't it?
Shall I come back in, Nadia?
Go for it.
It's such a disaster, and it's so depressing that this has happened, and the Green Homes grant has just been such a total cock-up. There's clearly loads of demand for heat pumps, and that's the exciting thing. So you will still be able to get your RHI money up until the end of April next year. So even if you were getting the Green Homes grant for a heat pump, you could then claim the RHI, and you'd get more probably from the RHI than you would from the Green Homes grant. So if you claim the Green Homes grant, basically it just allows you the cash up front, and it saves you financing a bigger system. Honestly, I wouldn't put money on doing anything around this, particularly if you're relying on that grant, because it just seems to be totally chaotic at the moment. And I was reading another report today in The Guardian. It's the third story they've run on it, so it shows what's going on, that said the money won't be rolled over until next year. So I'd say if you can definitely finance your heat pump yourself, there's no reason why you shouldn't do it. But if you're going to be reliant on the Green Homes grant, I'd be a bit cautious.
That's really good to know. And the Green Homes grant was actually extended, wasn't it, from the original sort of deadline that they had. So there are changes being made to it, but we're sort of waiting to see how it's going to be smoothed out. Is that right?
I think that's the theory. Although I'm not sure there've really been any official government communications from the department around this.
Sure. Okay, great. Thank you, Richard. So I hope we managed to answer most of your questions, and it looks like quite a few of you have had your questions answered in the chat as well. But the next section that we have got is the panel discussion. So I'd just like to introduce our speakers very, very quickly, and we get straight into questions again. So Shivali is the heat network specialist at the Department for Business, Energy and Industrial Strategy in the UK government. She's got a bachelor's in engineering, and she's also done her MBA at Durham Business School, which is wonderful. Been in the sector for over 15 years, but her career has mainly been at Daikin, where she was a specialist in future energy markets. And many of you will recognise Daikin because it's one of the biggest sort of heat pump manufacturers around. And she's really passionate about the heat sector and about creating smart cities. So how heat pumps and low carbon heat can play a role in merging with all the other tech that we have around renewables as well. So thank you, Shivali, very much for joining. And we also have Dr. Richard Lowes, who you've just heard from. Dr. Richard has a PhD in energy policy, and it's focused on sustainable heating from the University of Exeter. He's worked on heat decarbonisation for almost a decade, and you wouldn't expect it because he looks so young. Doesn't show at all, Richard. And Richard also tweets quite frequently and has a blog about sustainable heating, and I'll try and find a link to that blog and pop it in the chat as well. Richard, as I understand it, is also an avid DIYer, and you've installed a heat pump in your own home. Is that right, Richard? And a number of other energy efficiency measures.
Yeah, that is correct. I didn't install it myself, but I was closely involved with the design and specification. But I certainly didn't put the pipes in myself.
Amazing. So watching over them with a close eye.
Yes.
Great. So I am just going to stop sharing my screen because we've got a few questions to kick off with that I wanted to ask you guys. And the first one for both of you, Shivali and Richard, is how do heat pumps actually fit in with the other renewable energy tech that people have got in their home? You know, when we talk about an integrated system and a smart city, what does that actually mean? You know, what role do heat pumps play?
Richard, should I go, or do you want to first go on your DIY experience?
Go for it, Shivali, ladies first.
Thanks, Nadia. I think heat pumps play a very vital role, as has already been mentioned by yourself, by Jason, and Rana as well, that how important role they play after the electrification of transport is followed by heat. When you combine these with solar PV panels, say for instance, and I think there were around 14 or 15% people in the poll who said who have PV panels, then you're almost working in a model of self generation and self consumption. Whatever you're generating, you're using it. You're using your heat pump. Well, 9 months out of the 12 for hot water in that case. Then, and even in a little bit of light, I think PV panel owners have seen that you can still get output from the PV panels. When you complement them quite well with solar thermal panels, which is what I've got, and I feel it's a very good combination of a solar thermal panel and a heat pump personally. From a perspective of, again, you are using that for hot water purposes, and you've got a big tank where you store the water at the right times. And I think some people did also mention that they have time of use tariff, very small number. Where again, when we in a smart home, if we are discussing about if you've got a solar thermal panel with storage, thermal storage, and a heat pump, you can very intelligently use your tariff plan on storing it at the off-peak time. So running your heat pump at the off-peak time, and then utilizing the heat from the storage at a peak time. So you get the benefit on the running costs. And hence, I know majority of us said that we want to have a heat pump for carbon savings. I think it was in the poll, Nadia, you told us, shared the information, which is really encouraging. However, apart from carbon as well, I think they do play a role on helping to reduce the running costs. And that's merely also because of the efficiency, which Jason alluded to when he mentioned about the ground source and the air source heat pump from 4-to-1 or 3-to-1. And that's where you get another layer of savings on the running costs. Another benefit, if I see a bit more futuristic, and we see that yes, the weather is getting slightly warmer in summers. The other advantage is in a smart home is heating and cooling, which the heat pump provides another added advantage. So I would say from a smart home perspective, and I haven't even added what probably Rona might be thinking of is the EVs. If you combine electric vehicles with heat pumps and solar PVs, that's quite a combination from best electricity consumption perspective. And I'm sure Richard might have something to add from his own personal experience.
Only the thing missing from my house is an EV, which I can use to power my heat pump. So I'm basically doing all of the things Shivali has mentioned. I don't have solar thermal, I have solar PV, and there's a 2.4 kilowatt system just above my head. So I'm in a terrace, very similar to a typical London terrace, actually, about 100 square meters, just less. And the PV, so I have a combination of a solar PV plus the air source heat pump, and I'm on a time of use tariff. So how it works for me is that I can basically charge up my hot water with the solar PV. So it's not quite as efficient as solar thermal, but it's not too bad because the solar PV goes through the wires to the heat pump, and then the coefficient of performance of the heat pump, the efficiency, brings their overall efficiency back up. So basically my heat pump is set to run at certain times of day. So I charge the hot water up always over lunchtime and also in the middle of the night. And the heating goes off between 4 and 7 p.m. And that's aligned with the Octopus Energy Agile tariff, which is a time of use tariff, which varies. So it changes every half an hour, but you have a forecast of timing every day, but you always know that the 4 to 7 p.m. peak is the most expensive time. And so through, sorry, there's some feedback there. So through all of that, I'm getting probably an average electricity cost of about 10 pence per kilowatt hour compared to maybe 15 or 16, which you get on the market. And I'm actually getting very good heat pump performance. I'm getting a COP of about 3.6, 3.7 through my air source unit. So it's cheaper than gas, which is great.
That's really, really interesting. And so I know that, Rona, you might want to pitch in on this question, but I want to ask you guys, if everyone decided tomorrow that they wanted to get a heat pump, aside from the issues that we're having with installers, what would it mean for the UK? What would it mean for the wider system?
Yeah, I think if everyone decided overnight that they wanted one, it's probably a good job that there's some supplier shortages as well. I think, like what Richard was describing with the time of use tariffs, we will see more of those. We will see a lot more of those. Right now, the Octopus Agile tariff is one of the only ones, unless you consider the retro Economy 7 and Economy 10, which is where you get cheap electricity overnight, either 7 hours or 10 hours, depending on which one you're with. So I think that's really going to be the key way to make sure that people can have reasonable costs for electricity, because ultimately, if everyone got a heat pump and everyone came home from work and charged their electric vehicle and wanted to warm up their house and roast their chicken in their electric oven, it would be a lot. And to make sure that the network was strong enough to deal with that level of peak demand, there would have to be changes. And I just wanted to follow on from a point someone else made earlier about people do worry about this, and I think it's a rational thing to be worried about. But what I'd like to reassure everyone is that the electricity network is built to withstand the peak demand, so the highest amount of demand on the busiest day of the year, and the rest of the time it's underutilized absolutely massively. So if we can have clever things like clever tariffs, and like I have a Nest, so I can set when I want things to be on or off, so that it's warm at the right times for me. If you can do that, then actually there will hardly be any changes to the network required. I don't know if I answered your question properly, Nadia.
Yeah, no, that's really, really useful. So it's all about when people are using energy and how the system can cope with that. So, equally, if everyone was to be watching the FA Cup final and then they all went in half time to boil their kettle for a cup of tea, it would be a lot of demand on the electricity system. But you're saying that there shouldn't be concerns because the system is built to manage, the highest amount of demand there is possible. So you're looking at making sure that it utilizes all of what it can do throughout the year, really, not just when it's a really busy time.
Yeah, and I think that's what people would like as well. I mean, if everyone in the UK said, no, I don't want a smart charger, or I don't want to do whatever, I want to be able to do this, then it probably means that bills would go up to respond to that. But there will be, I think, a best system where you have the right level of flexibility and the right level of adjusting the network to suit everyone.
Mm-hmm. That's really good to know. And so Richard, Shivali, any sort of points on this one?
Yeah, I'd just like to add to what Rona said. She's best placed actually in this scenario that, and you gave a very good example of the football match, Nadia. If you all put the kettle on, there'll be a spike at the network. But just to reassure that an increase in the electrification of heat will, yes, impact the electricity network as the demand for electricity increases. But government is working very closely with Ofgem, which is the regulator, the electricity system operator, DNOs like UKPN, and the Energy Networks Association as well. So there is an association who works quite closely with the DNOs to assess the network impacts from this increased deployment of heat pumps. So it's just to assure and put that across, and just say another line on Rona. I think Rona mentioned about the flexibility as well. There's a lot of work which is happening to investigate the flexibility potential of heat pumps as well, and the impact that can have on shifting the electrical demand from heat pumps. So if everyone is thinking about it, so please still go and take the right decision for your home.
And just quickly, the thing about heat pumps is it's not like a boiler where you turn it on for an hour and then your whole house is warm. You tend to actually have them on for a longer period of time because their peak heat output isn't super high and all the rest of it. So it generally, like, it plays into what works for the networks, which is, a longer, flatter demand.
Okay, that's really good to know. And really, this is a bit of an unfair question, But I'd like to know, do you think that heat pumps are the best solution for decarbonising heat?
That should be a poll question, really, shouldn't it? For lots of people, I think the answer is yes, but probably not for everyone.
Do you mind if I come in, Nadia, on that question?
Yeah, go for it, Richard.
So the work I've been involved with and various other bits of analysis, so this is work at the UK Energy Research Centre, really strongly point towards heat pumps as being the cost-effective solution for the vast majority of homes. I think the Committee on Climate Change's numbers is actually that by 2050 to get to net zero, either your home is connected to a heat network, or so if you're in an urban area, or you have a heat pump of some variety, and that could be an air source, a ground source, or maybe a hybrid heat pump topped up with something else. But actually the number of heat pumps by 2050 in the cost-effective scenario is 19 million, which is the vast majority of houses. The only other alternatives really are to provide the actual total heat demand across the year for a house would be some sort of low carbon gas, whether that's a biogas or a hydrogen, but none of those things are really done at scale, and they're not necessarily scalable, and they all look a lot more expensive. So there aren't many options, and heat pumps, because they're so efficient, and that's the point of them, always appear as a good cost-effective option. Not easy though.
So heat pumps.
Sorry, Nadia.
You can hear. Yeah, go ahead, Shivali.
It's interesting, the question you asked. Along with transport, the heat in buildings is one of the biggest source of greenhouse gas emissions in UK. And to give a perspective, that accounts for around 23% of total UK emissions. From an options perspective, yes, I agree with Richard that heat pumps are an efficient electric heating appliance and have a critical role to play. But there are a number of options with the potential to play an important role in decarbonizing heat. And that includes heat networks, definitely with heat pumps, hydrogen, and biogas. Yes, I agree, Richard, about the scale and the trials being happening. But I would say these are in the mix. But coming back to heat pumps point, I would like to also just mention that it was set out in the 10-point plan from the Prime Minister as well, and also quoting the Energy White Paper, that we have set an ambition to grow the market to 600,000 heat pump installations per year by 2028. So that does speak volumes, I think, about the technology too.
That's really good to know. And we've actually got a question from Jamie around that. So what sort of support is there for green jobs and for making sure that those supply chains for heat pumps are going to grow whilst the demand grows? I mean, we've seen demand grow around the Green Homes Grant quite a bit, so people are really interested. But yeah, what is government doing in that area to make sure that heat pump installers are supported as well?
Absolutely, very good question. I would say, Jamie, sorry I missed the chat. I'm not looking at the chat at the minute, but thanks for reading that, Nadia. So BEIS are working quite closely with the industry to establish how we can expand the installer base in line with the demand, and really ensure the installers have the right skills. That's quite into our radar as well. There are currently around 1,800 qualified heat pump installers in the UK. That number might have increased. This might be the number from maybe a few days back. But this is according to a recent Heat Pump Association skills report. And that's the report. The same report suggests that to install 600,000 heat pumps a year by 2028, we require training of 30,000 new installers. And industry suggests there is currently capacity to train 7,000 new installers each year. So what I'm trying to give an idea is that these numbers are quite into our radar. We are working with the industry. So two important things in the skills base is to expand the installer base, but not only expansion, but ensuring the right skills is quite important for us. We are currently undertaking a research with impact research, which is due to be concluded early this year. The idea of this research is to explore how to drive existing installers to retrain in the low carbon heating. So, just getting upskilling and further understand the attitudes to future heating regulations, which is quite key in this aspect. And alongside the Committee on Climate Change, the department is also feeding into the research conducted by the CITB, which is the Construction Industry Training Board, and it constitutes a skills analysis based on expected net zero deployment trajectories. So it's quite, I think from assurance perspective, I'm trying to mention that the work we are doing across for this technology. The department is supporting the industry in updating heat pump installation and training standards to ensure that the installers have consistent, up-to-date, and high-quality training. The department is also working with the industry and across the government, actually, to ensure that technical education provides new entrants with the skills needed to install the low-carbon heating. So hopefully, Jamie, I've answered your question.
Yeah, that's really helpful. So if anyone's interested in getting into renewable energy, have a look at all the heat pumps training that's out there.
Yeah, Nadia, if you don't mind, I'll just add to that yes, I completely agree. There is a skill shortage at the moment, and as you know, being an installer in the industry, we are training people as quickly as we can, but we are, you know, we do realise there is quite a challenge ahead, and we're sort of, you know, working with the government and you know, Ofgem and all of the organisations to try and make that happen. It's a challenge. No one is denying it's a challenge, but it's a challenge we're all facing together and we're all working towards solving at this point. ISO specifically, just talking for us, we've literally at the start of this year just had a whole new building built at our office, specifically for training purposes. So that will be training in heat pumps, but it will also be training on all the technologies that we see moving forwards: EV charging point installation, batteries, PV, solar thermal, and it will be very much a plug in and plug out of various technologies as we need to train installers. So yeah, moving forwards, obviously we're looking at you know, training as many people as possible in this area and really sort of pushing the industry on, because we recognise that it will continue to grow at quite a drastic rate, as Shivali has mentioned.
That's really good to know. So a lot of jobs going, and we're waiting for the industry to grow and see a lot more people start to take up heat pumps as well. So that just brings me on to sort of the final question. If people can't get a heat pump right now and they want to, for whatever reason, you know, maybe the wait times are too long, maybe they're a bit too expensive, they don't have the funds right now. If they have, you know, recently had a new boiler put in and they weren't actually thinking about a heat pump at that point in time, 1 or 2 years ago, are there any things that people can do that can prepare them for getting a heat pump, or is there anything they could do now as a bit of an alternative?
Is that right if I come in?
Go for it.
So, I mean, there are various things you can do. Really, when you want to get your heat pump, you want your house to be fully insulated. So you want as much insulation as possible, and sometimes that's easiest to do room by room. So if you're doing internal wall insulation like I've got just behind me, when new plaster went up, that was the time to do that. And if you're redecorating a room, it's a good opportunity. Not always possible, but there are sort of incremental improvements you can make. The other big thing is making sure that your actual heating system is ready for a lower flow temperature. And so often that's just as simple as upsizing radiators. It's not always the case. It might mean changes to some of the pipe work. But quite often you might need to have, particularly if you've got single panel radiators, where you've just got one layer, they're likely to need to be at least double panel radiators. So think of it as a room by room thing, and get it ready. And if you can get so what you want to do is you want to get your gas boiler running at below 55 degrees, basically. And you can probably see the knob on there, and it will show you, if not, there's a number. And if your system is running at 55 degrees, you can actually quite easily, I say easily, it's possible to run a heat pump at that sort of temperature. But to make that happen in the first place, you're likely to need bigger radiators. So you can make sure that your house is efficient, insulated, and able to take a lower flow temperature in the meantime, I probably wouldn't encourage anyone to take out a gas boiler before the end of its life, because resources have gone into that gas boiler, and it'll be much easier and much more cost effective for you to wait for that to come to the end of its life.
That is really, really helpful. Thank you so much, Richard. That's really useful to know. Any other speakers, any sort of tips on what people should be doing to get prepared or doing now? I mean, obviously the fuse upgrades is something to look at from UKPN or from Rona's perspective, which we talked about earlier.
Yeah, I think especially if your house was built before sort of 1980, it's worth, yeah, looking into it. If you are seriously thinking about getting a heat pump at some point.
Great, wonderful. So I think we are running out of time, I'm afraid, but I just wanted to say a really, really big thank you to all of our guest speakers who've donated their time today completely free. So really, really do appreciate you guys joining us for this webinar and giving out all of your very, very high level of knowledge and explaining your experience to us as well. I just wanted, as a final roundup, to tell people what you can actually do today after the webinar right now. So if you're interested in heat pumps, if you're interested in making your home greener, more energy efficient, do give us a call. You can book a free half-hour with us, with one of our advisors, David, Tristan, or myself, and we'll run through what your options are for lowering your carbon emissions in your own home. If you're able to invest some more money, do consider a deep retrofit. And when we say deep retrofit, I think, as you mentioned, Richard, a good way to look at it is do it room by room. But also factor in, you know, what other works you might be getting done soon. So check out the blog on our website to find out a bit more about your options there and how to approach the topic, which can be a bit daunting. But of course, feel free to speak to us if you are finding it a bit daunting. And if you're outside of London, do visit the Community Energy England website to find out who your local community energy group is. And if you've enjoyed this webinar, please do leave us a Google review. It would really help us get the word out a bit more about what we're doing. And I'm just going to post the link in the chat just after I stop sharing. But for now, I would just like to say a huge thank you to all of our speakers and everyone who has attended. I hope you found it useful. And thank you for all your donations to support our fuel poverty and carbon saving work. And I will be sending round the webinar recording, the slides and the chat. So don't worry about any little links that you've missed here or there after this session. But please give me a few days so that I can get those bits out. And I do hope to see you on one of our future events or our future webinars. Feel free to get in touch. Again, any questions that we missed, anything you want to get in touch with our speakers about, just drop me an email, nadia@celsie.org.uk, and I will put you right in touch. But I think we will leave it there. We'll leave you to all go and have dinner and enjoy the rest of your Wednesday evening. And thank you all for joining.